radian per second square. So that is why now instantaneous, alpha instantaneous. So alpha instantaneous is given by d omega by dt. So this time you want to find this at t is equal to 2 second. Basically this time you have to differentiate this equation. So dy dt of omega, omega is t square plus 1. So this differentiation, this will become 2t and put the value of t as 2. So you will get your answer. So it will become 2 into 2, that will be 4 radian per second square. Okay, 4 radian per second square you will get. Okay, so this question we will solve. So mod v means speed. Remember, speed means magnitude of velocity. Magnitude of velocity. So this is the question. If speed mod v is equal to constant in a circular motion, so what can you say about the tangential acceleration? What can you say about the centripetal acceleration? What can you say about the net acceleration? What can you say about the alpha? Whether they will be constant, they will be, they are not asking the value, they are just asking uh, whether they will be zero or they will be not zero, they will be constant. Okay, so we will check. So first is the tangential acceleration. So tangential acceleration can be written as the, what is tangential acceleration? Tangential acceleration is basically dv by dt. Na? If the speed is changing, then only tangential acceleration exists. Otherwise, this is equal to 0. Second part. So dv by dt differentiation when you will do, v is constant, differentiation of constant term is equal to 0. In this way also you can solve, and in another way you can say that if speed is constant in a circular motion, then there will be no tangential acceleration. Tangential acceleration is due to change in the speed only. Now centripetal acceleration. So what is the cause of the centripetal acceleration? Change in the direction. So if the body is moving in a circular motion, direction will always change. So there will be the centripetal acceleration. That centripetal acceleration is given by speed square divided by r. Okay, and speed is constant, so this value will be constant. Radius of the circle will be constant. Now third is the net acceleration. What is net acceleration? So net acceleration contains tangential acceleration and centripetal acceleration. Now this tangential acceleration is equal to 0. Okay, you can see here if the speed is constant. But there is some centripetal acceleration and that is constant. So what can you say about the net acceleration? So there will be net acceleration and net acceleration will also be constant. Okay, because net acceleration will be this now, at square plus ac square. So this will be 0. Basically net acceleration is equal to centripetal acceleration. Okay, when you will solve, you will get net acceleration is equal to centripetal acceleration is equal to constant. Alpha. Now last part you have to solve, Hiva and Divyangi. Alpha. What can you say about the angular acceleration? Fourth part. What can you say about the angular acceleration? First. Will it be 0? Will it be constant? Okay, I have told you that tangential acceleration is equal to radius times of the alpha. So tangential acceleration is 0. That is why alpha is equal to 0. So if 0, you can say alpha. If something is 0 means 0, you can say constant also. Okay, next question. Okay, so what they are asking, if this constant means the speed is constant in a circular motion, this is dv by dt. This dv by dt means total change in velocity. Okay, this dv by dt means, here dv by dt means total change in velocity. This is total change in velocity. And basically this is a change in the velocity with time. This is total change in velocity with time, and this is d omega by dt. Okay, rate of change of. So we will see answer number first. Basically total change in velocity will be equal to the net acceleration. Basically net acceleration is due to total change in velocity. So if the speed is constant, then net acceleration will be there or no? Dibyangi, if the speed is constant, whether there will be the net acceleration or not?
Yes, sir.
Why?
Centripetal.
Wow, very good. The net acceleration will be there because of the centripetal, and this is speed is constant, so this net acceleration will be centripetal acceleration, and this is equal to constant. Second part, this value is basically the tangential acceleration. So I have told you this will also be 0. Why? Because this is given that here mod v is equal to constant. Speed is constant, so this is the tangential acceleration. If speed is constant, then there will be no tangential acceleration. Now third part, d omega by dt. What is d omega by dt? Alpha. So there is a relation between alpha. So this is 0. So alpha is equal to 0. So in third part, d omega by dt is equal to 0, and this is also 0, and this is equal to constant. Is there any other question here? Okay, this question. Okay, so first what you have to do, please write down the questions and answer of this first question. Okay, when completed, just tell me. Okay, then write down the other question and answer, then more question we will solve. Please write down little bit fast because we do not have enough time. We have a 1 hour class only. Oh. Okay, just wait. First you have to write not this. First you have to write. uh, I think from where I have started. Okay, first you have to write this. Sorry. Okay, first write this, then we go to that. Okay. This write this relation also. So don't say that acceleration is equal to radius into angular acceleration. This is the tangential acceleration. Okay, this is only tangential acceleration because this is not the vector form. This is a scalar form. Hiba, complete it.
So,
Okay, so now you can write this. So in this question, the angular velocity is a function of time. Means with time, the angular velocity of the particle is changing. And I have told you that if a time period is given, a finite time period in 0 to 1 second, 0 to 2 seconds, 0 to 3 seconds, finite time period is given. Then means you have to calculate average. If they are asking at 2 second, at 3 second, at 5 second, means they are asking at that instant. So you will calculate the instantaneous value of uh, of any quantity, not only for the acceleration. That can be the velocity, that can be the current, that can be the magnetic field, that can be the electric field. And after this, we will discuss the one of the most important concept in the circular motion. Okay, centripetal force. Okay. Okay, so you can, if you have not completed and suppose I have scrolled down, so you can ask me to scroll up also. Okay, write down this. Okay. Completed. Byangi and Hiba.
Yes, sir.
Yes, sir.
So this is the last question, and write down this question, and this is your homework. Try this question by yourself. They are asking here if v is constant. This is the true false type question. Okay, so this statement is true or false. True or false, and you have to write the reason also. Okay, anyone can tell whether it will be true. That there will be a 50% probability for solving one question. So you have to write the reason also, why this is true, why this is false, with reason. The reason also you have to write. Here alpha is the angular acceleration, a suffix t is the tangential acceleration. This is centripetal acceleration. And tangential acceleration is due to change in speed in a circular motion. And centripetal acceleration is due to change in the direction of the velocity. Okay, so now we will discuss centripetal force. Okay, so centripetal force. So we know that the earth revolves around a sun. Okay, and we consider that basically the earth revolves in a circular orbit. Okay, exactly that is not a circular orbit, but we consider that earth revolves around a sun in a circular orbit. So for explaining that circular centripetal force, this is the earth, and here is sun. Sun is much bigger than earth, we know that, and this earth is moving in a, now focus on the earth, what the earth is doing. Focus on the earth. Basically you are observing the motion of the earth from the center of the sun. Just imagine. So basically the why the earth is revolving, just we know that na earth revolves around the sun, we know that. That is why there are uh, various phenomena are taking place. Okay, so and there is one more thing that I want to tell you. Each and every body has a tendency, natural tendency to move in a straight line. Okay, so everybody has a tendency to move in a straight line, but here this earth is revolving around the sun in a circular path. So this is against the nature. We can say this is against the nature. If nature wants that this earth should move in this path like this, nature wants this thing move tangentially or in a straight line. So this is against the nature. Okay, so what happens now here? If the earth is rotating around this sun, so definitely there will be a force that is responsible for the circular motion of this earth. Definitely there will be a force that is responsible for the circular motion of this earth. Okay, so and in this case, forget about the centripetal force and all that. Can you tell me what kind of force will be there between the earth and the sun? Divyangi, between the earth and the sun, what kind of force will be there? Gravitational force. Very good. Between the two masses, we will study this thing in the gravitation. If there are two masses, there will be the gravitational force between the two masses, equal and opposite. So basically on this earth, and this gravitational force is always attractive in nature. So basically the center of the sun will attract this earth with the gravitational force. So here is the gravitational force. Okay, so basically what I want to say, this earth is revolving around the sun. Centripetal force is basically nothing. Centripetal force is basically nothing. You can say centripetal force is the force required by the body, okay, required by the body to move in a circular path, and that centripetal force is nothing but that centripetal force is provided by some other force, or you can say some force. That can be the gravitational force, that can be the electrostatics, that can be the friction force, that can be the normal reaction, that can be any other external force. Okay, so here is what force? Here is the gravitational force only. In this case I am just considering here is the gravitational force on this earth. So basically for the centripetal force, here will be the gravitational force, and details we will discuss here. Okay, so I have already written all the things to save the time. Basically centripetal force required by body, you can write here, force required by body for moving in a circular path, and this force is provided to body by some other force like tension force like gravitational force, like electrostatic force, like friction force, etc. And basically the main point you have to remember here for solving the question, this point will help you a lot. Centripetal force is basically the net force towards the center. Centripetal force is basically the net force towards the center. In the previous example also, you can see here, okay, no problem. So net force toward the center, this statement you have to know. Net force toward the center. Now, net force toward the center. Okay. Now, how we will just derive the expression for the centripetal force? Basically, this point should be clear first. Force required by the body for motion a circular path. This force is provided to the body by some other force like tension, gravitational, electrostatic, friction force. This statement help you a lot, and this statement also will help you a lot. After that, I want to write, is there any formula for the gravitational force? If I am saying that for the centripetal force, if I am saying that the net force toward the center is the centripetal force, that will be enough. There is one formula also, and basically that is given by that net force is given by that net force toward the center. Okay, and if there will be the net force toward the center, so due to the force there will be the acceleration also. And in the last classes I have told you, when a body is moving in a circular path, there is a type of acceleration toward the center that is known as the centripetal acceleration. If suppose this body will be here in circular motion, then you can say the centripetal force, centripetal acceleration will be like this toward the center. Okay, so there is a centripetal acceleration in a circular motion, and if there is an acceleration, so according to the Newton's second law, if there is an acceleration, so you can say there will be the force. This acceleration is toward the center. Okay, and this is the mass of the body m. This body of particle of mass m is moving in a circular path and having the centripetal acceleration. So can you calculate the force by this acceleration? That is mass into centripetal acceleration. And we know that if this mass is moving with a velocity of v, constant velocity of v, okay, this is the not the velocity, this is the speed or magnitude of the velocity. So I can write this AC. What is the formula of AC? V square by r. R is the radius. So basically centripetal force, first formula of centripetal force is this. Basically mv square by r is first thing that you have to remember. Mv square by r. Okay, another, we know that this body, this mass is performing the circular motion. So I can write v is equal to r omega. If there is a speed, so there will be the angular speed also. Omega will be all there, angular speed. Okay. So now when you will put v is equal to r omega, so it will become r square into omega square, and r will be cancelled out. So what you will get? You will get this centripetal force. Basically, this is the centripetal force Fc. M r omega square. Both the formulas will be used accordingly, according to the situation. So remember this also. Now, for example number 1. This is a string and this is a mass, and this mass is like I have mass attached in a string, and the mass is rotating like this. Okay, you can imagine what I want to say. The mass is rotating in a circular orbit, circular path. Basically, this mass is rotating in a circular path like this. Okay, this mass is rotating in a circular path like this. Okay, so if I am asking this mass is rotating with an angular velocity of omega. This is the angular velocity of the mass. If I want to find the tension in the string, if I want to find the tension in the string, then how can I find the tension in the string? So basically, first decide the direction of the tension. The direction of the tension will be away from the mass. I have told you, with respect to the mass, the direction of the tension will be away from the mass. So basically, this mass is performing the circular motion. Okay. So for the circular motion, there is a requirement of the centripetal force. And what is centripetal force? Net force towards the center. What is the net force towards the center? This is tension. And what is the formula for the centripetal force? And this distance is suppose L. The string length is L. Okay. So you can write M instead of R. You can write L into omega square is equal to T. So basically, tension in the string will be ml omega square. So in this way, you have to use the. So which force is providing the centripetal force to the mass? Here is the tension force. Tension force is providing the centripetal force. Now in this case, see. In an atom, electron, proton, neutron. So in an atom, electron revolves around the nucleus. Okay, in circular orbit. So basically, here electron is performing the circular motion. So for the circular motion, there is a requirement of centripetal force, and in between the nucleus, nucleus is positively charged, electron is negatively charged. So there is a electrostatic force of attraction. So here electrostatic force of attraction will provide the centripetal force. Okay, electrostatic force of attraction, that is Fe, electrostatic force of attraction. So here Fe will provide the centripetal force to the electron, so that the electron will able to move in a circular path. Now Earth revolve around the sun. So on the Earth, gravitational force is acting. So in other from the other perspective also you can solve this. What is the centripetal force for the Earth? If the Earth is moving in a circular path, so there must be a centripetal force. And what is the centripetal force? Net force toward the center. What is net force toward the center? That is gravitational force. Or in other word, you can say the gravitational force will provide the centripetal force to the Earth for the motion in the circular orbit. Okay, here is particle P, and on this particle is moving in a circular path, and at this point on this particle, F1 force is acting in this direction and F2 force is acting in this direction. Okay, so we have to find how the centripetal force will be here. Okay, what will be the centripetal force will be here. Okay, so what is the centripetal force? Centripetal force is basically net force towards the center. Net force towards the center is F2 minus F1. Okay. And centripetal force is also given by mv square by r and mr omega square. Okay. So now write down. Basically, here we are discussing dynamics of circular motion. So dynamics means when we are talking about the cause of the motion. So that is known as the dynamics of circular motion. Dynamics of circular motion. Oh, okay. So actually net force towards the center. Okay. So if you want to find the direction of the centripetal force, so centripetal force is always towards the center. Okay. Will always towards the center because I have told you net force towards the center. So direction, if you want to write, then you can say always towards center. Always towards center. So you can show here. Okay, here will be the centripetal force like this. Here also you can show centripetal force. From the centripetal acceleration, we are getting the centripetal force. Basically, you have to relate all the things here. Okay, completed, Hiba?
Yes, sir.
Write down this formula of the mr omega square. Okay, mr into omega square.
So can you scroll up?
Scroll up. Okay. So you have to focus on the body which is performing the circular motion. Here this mass is performing the circular motion. So you have to observe this mass. You can observe the string also, but that is not the case here. Basically this mass is performing the circular motion. We have to analyze the motion of the mass, not of the string. So this mass is performing in a circular path. So I have told you for motion in a circular path, there will be a requirement of centripetal force, and that centripetal force is equal to the net force toward the center. Now, after that, you have to check which is the force which is toward the center. Here is the tension force toward the center, and this is the net force also. So this will be equal to. So in this way, you have to think. So don't say always that centripetal force is equal to mv square by r or mr omega square by r. Okay. That is centripetal force mv square by r, but whole concept you should know. Centripetal force is equal to the net force towards the center. Okay, and that net force is equal to the centripetal force. And centripetal force, if you want to write formula, m r omega square, r can be the radius or r can be the, basically r is the distance from the center. So when a body is moving in a circular path, so basically what is happening? Velocity direction changes. So due to that velocity changes. If the velocity will change, there will be acceleration, and that acceleration is centripetal acceleration. And centripetal, due to that centripetal acceleration, there will be the centripetal force. In this way also you can explain. And that centripetal force is provided by some other force. Centripetal force is basically a name. Basically, centripetal force is just given by some other force. Centripetal force is not a new force like electrostatics, like gravitation, like friction, like a spring force. Sometimes spring force can also be the centripetal, sometimes gravitational force, sometimes friction force, sometimes tension force. Scroll down.
Yes, sir.
So in the next class, we will solve the questions related to the centripetal force. Okay, so there we will use all the concept that I have told today. So please make sure that revise all these things, because in the next lecture we will discuss some of the things which in which there will be a requirement of these concepts. And try the question that I have given for homework. Okay, if you have completed, then you can leave the meeting. We will meet in the next class. And if you want to ask any doubt, then you can ask me.
Thank you, sir.